Hi students, today discuss the topic product of determinants. Already you know product of two matrices is using only one way. The one way is row by column method. But the product of determinant is there are four types. Four multiplication rule. The first one is row by column method rule. Next one row by row multiplication rule. Next one column by column multiplication rule. The next one column by row multiplication rule. There are four types. Product of determinants. The first one row by column multiplication rule, and the second one row by row multiplication rule, and third one column by column multiplication rule, and fourth one column by row multiplication rule. There are four types of multiplication rule. That is a product of determinants. The product of determinants, the first one note, then determinant of AB equal to determinant of AB value, determinant of AB equal to determinant of A into determinant of B. Determinant of AB equal to determinant of A into determinant of B. The next one, multiplication of two matrices AB is not equal to BA. AB is not equal to BA means matrix multiplication is not commutative. Means AB is not equal to BA. AB is not equal to BA. As usual, matrix multiplication is not commutative. AB is not equal to BA, but the determinant of AB is always equal to determinant of BA. Determinant of AB is always equal to determinant of BA. Both are equal. That is the determinant of AB equal to determinant of BA. Product of determinant based on example problem. Example 7.28 show that determinant of 0CB, C0A, BA0 whole square equal to determinant of B square plus C square, ABAC, AB C square plus A square BC, AC BC, A square plus B square. The product of determinant based on example problem. Example 7.28 show that determinant 0CB, C0A, BA0 whole square equal to determinant of B square plus C square, ABAC, AB C square plus A square BC, AB BC A square plus B square. Then determinant of whole square, we have to prove this result. Now taking LHS equal to RHS, we have to prove LHS equal to RHS. Now I am taking LHS. LHS is determinant 0CB, C0A, BA0 whole square. That is whole square is expanding two times in the determinant. That is the first one, determinant 0CB, C0A, BA0 into, okay, one time in the determinant 0CB, C0A, BA0. Now product of two determinants. Product of two determinant is in four ways: row by row method, row by column method, column by column, or column by row method. Any one way. Now find the result. The RHS value B square plus C square, AB, AC. This one result we have to prove. Now multiply row by row method or row by column method using any one way. Now first multiply row by column method or row by row method anyway. Now multiply row by column method. Row by column is first row, first column, first row, second column, first row, third column, as usual. That is equal to first one multiply row by column method rule. 0 into 0, 0. 0 into 0 is 0. Next one C into C, C square plus C square. Next one B into B is B square plus B square. First row, first column is over. That is the result is 0 plus c square plus b square. B square plus c square. You have to prove the result b square plus c square. That is row by column method. You take row by row method. Row by row method is row by row, first row and first row. 0 into 0 is 0. C into c, c square. B into b, b square. Answer is 0 plus c square plus b square plus c square. As usual, the same result. You multiply row by row method or row by column method, anyone. Now I am taking row by column method rule. First row, first column is over. Next one, first row and the second column. 0 into c is 0. 0 into c is 0. Next one, c into 0 is 0. Next one, BA. A into B is AB. First row, second column is over. Next, first row and third column. 0 into B, 0. C into A is AC. Next, B into 0 is 0. 0. That is first row is over. Right in second row and first column. C into 0 is 0. 0 into C is 0. Next one, A into B is AB plus AB. Next, second row and the second column. C into C, C square. C into C, C square. 0 into 0, 0. Next, A into A square plus A square. Second row and third column. C into B is BC. 0 into A, 0. Next one, plus A into 0 is 0. 0. Second row is over. Now write it third row, third column. Now taking third row into first column. B into 0 is 0. A into C, AC plus AC. Next one, 0 into B is 0. Next one, B into C, third row, second column. B into C is BC. Next, A into 0 is 0. 0 into A is 0. Plus 0. Next, third row and third column. B into B is B square. B square. Next, A into A is A square plus A square. 0 into 0 is plus 0. The result is 0 plus C square plus B square is B square plus C square. That is equal. That is the determinant. C square plus B square is B square plus C square. B square plus C square. Next one, 0 plus AB, that is AB. Next one, AC. And the second row, 0 plus AB is AB. AB. Next one, C square plus 0 plus A square is C square plus A square. And third one, BC plus 0 is BC. And third row, 0 plus AC plus 0 is AC. And second, BC plus 0 is BC. Last one, B square plus A square plus 0 is A square plus B square. You have to prove the result. Take LHS equal to RHS. RHS is B square plus C square, AB, AC, AB, C square plus A square, BC, AC, BC, A square plus B square is RHS. Therefore, LHS equal to RHS. Hence proof. Next example 7.29. Show that determinant of 2bc minus a square, c square, b square, c square, 2ca minus b square, a square, b square, a square, 2ab minus c square equal to determinant of abc, bca, cab whole square. Now, taking right hand side, taking RHS, we have to prove LHS. We have to take RHS. The right hand side is determinant of ABC, BCA and CAB whole square. This whole square is expanding 2 times. Write in 2 times in the determinant ABC, BCA, CAB into, again one time write in the determinant ABC, BCA, CAB. Now multiplication of two determinants. Multiplication of two determinants by using row by column method or row by row method, any one way. Now multiply row by column method rule. This row by column, first row in first column is a into a is a square, b into b is b square, c into c is c square, a square plus b square plus c square. If the result is a square plus b square plus c square, we want the result is 2bc minus a square. We have to prove the result 2bc minus a square, that is minus a square. We want the result is minus of a square, minus a square. This first row and first column is a square plus b square plus c square, not in result. Now I am interchanging R2 and R3. R2 and R3, interchanging R2 and R3. Interchanging R2 and R3 is interchanging any two row or any columns, only changes for sign only. Determinant of A equal to minus determinant of A. Any two row or any two columns are interchanging, only changes for sign only. Now the writing a first determinant is as it is same, A, B, C. Next one B, C, A. And the third C, A, B into I am interchanging R2 and R3. Interchanging R2 is interchanging R3. First row is as it is same, A, B, C. The next one interchanging R2 and R3 is C, A, B. And third row B, C, A. Two rows are interchanging, sign only change, that is minus 1. Minus 1. Now multiply in minus 1 in first row. Multiply by minus 1 in first row. That is equal. The first determinant is as it is same, A, B, C. And the second row B, C, A. The third row C, A, B. Into minus 1 is multiplied by first row, is minus A, minus B, minus C, and the second row as it is same, C, A, B, and third row B, C, A. Now multiplication of two determinants, row by column method rule. A into minus A is minus A square, B into C is BC, C into B is BC. As the result is minus A square, BC plus BC is 2BC. 2BC minus A square. We want the result is 2BC minus A square. That is the product of two determinants. That is equal. The product of two determinants is row by column method rule. A into minus A is minus A square. B into C is plus BC. C into B is BC. First row, first column over. First row, second column. A into minus B is minus AB. Next one, B into A is plus AB. Next C into C is C square plus C square. First row, second column over. Next one, first row, third column. A into minus C is minus AC. B into B is plus B square. C into A is plus AC. That is it. First row is over. And the second row, first column, B into minus A minus AB, C into C is plus C square, A into B is plus AB. Okay. First, second row and second column, B into minus B is B into minus B minus B square, B into minus B is minus B square, C into A is plus AC. Next one, A into C is plus AC. Plus AC. Second row, second column over, and the second row, third column, B into minus C minus BC, C into B plus BC. Next one, A into A is plus A square. Plus A square. Second row is over. And the third row, the first column, C into minus A minus AC, A into C is plus AC, Next one, b into b is plus b square. Plus b square. The third row, second column, c into minus bc, a into a is plus a square. Next one, b into c is plus bc. And the last, c into minus c square, a into b is plus ab, b into a is plus ab. Plus ab. That is equal, the determinant, minus a square plus bc plus bc. Plus bc plus bc, 1bc, 1bc, 2bc, 2bc minus a square, 2bc minus a square. The next one, minus ab plus ab cancel, remaining c square. The next one, minus ac plus ac cancel, the remaining element is b square. First row. The second row, minus ab plus ab cancel, get the element is c square. Next one, plus ac, add 2 times 2ac minus b square. 2ac minus b square. The next one, minus bc plus bc cancel, a square. Second row. The third row, minus ac plus ac cancel, is b square. Second one, minus bc plus bc cancel, a square. Last one, ab plus ab is 2ab minus c square. 2bc minus a square, c square, b square, c square, 2ac minus b square, a square, b square, a square, 2ab minus c square. That is, the result is LHS. That is equal to LHS. Therefore, the proof is, therefore, RHS equal to LHS, hence proof. And next example problem. Example 7.29. Prove that determinant 1xx, x1x, xx1 whole square equal to 1 minus 2x square minus x square minus x square minus x square minus 1 x square minus 2x, and last row minus x square minus 2x minus 1. We have to prove, take LHS equal to RHS. Now I am taking LHS, the left hand side is determinant 1xx, x1x, xx1 whole square. This whole square is expanding 2 times in the determinant. The first determinant 1xx, x1x, xx1 into the same determinant 1xx, x1x, xx1. Now the multiplication of two determinants. Multiplication of two determinants using row by row or row by column method rule. Now multiply row by column method rule. 1 into 1 is 1. X into x is x square. X into x is x square. That is, answer is, get the answer is 1 plus x square plus x square is 1 plus 2x square. Get the result is 1 plus 2x square. We want the result is 1 minus 2x square. 1 minus 2x square. We want the result is minus 2x square. Minus 2x square. That is, the second row is minus x and third row is minus x. This x into minus x is minus x square. X into minus x is minus x square. That is, 1 into 1 is 1. 1 minus x square minus x square is, get the result is 1 minus 2x square. So the second row and the third row is multiply and divide by minus 1. Multiply, divide by minus 1, get the result 1 minus 2x square. So in the second determinant in second row and the third row is multiply and divide by minus 1. In first row is, as it is same, 1xx, and the second row x1x, and the third row xx1 into the second determinant is second row and the third row is multiply and divide by minus 1. That is minus 1 into minus 1. That is second determinant. Second row is multiply and divide by minus 1 and plus minus 1 minus 1. This 1 x, right? In the first row is as it is same, and the second row is multiply by minus 1, divide by minus 1 is x by minus 1 is minus x. Minus x minus 1 is minus x. Third row is multiply and divide by minus 1, multiply by minus 1, divide by minus 1, x by minus 1 is minus x, minus 1. Now, minus 1 into minus 1, minus 1 into minus 1 is plus 1. Minus 1 into minus 1 is plus 1. The determinant as it is same, first determinant, and the second determinant is 1xx minus x minus 1 minus x minus x minus x minus 1. Next one, then the product of two determinants. Product of two determinants is equal, the first determinant as it is same, 1xx x1x xx1 into minus 1 into minus 1 is plus 1 into the determinant 1xx minus x minus 1 minus x, and third row minus x minus x minus 1. Now the product of two determinants. Product of two determinants by using row by column method rule. Row by column. Row by column is equal first row and first column. Row by column method rule. First row, first column. 1 into 1 is 1. X into minus x is minus x square. Next one, x into minus x is minus x square. That is, answer is 1 minus x square is minus 1 minus 2x square. That is the RHS result is 1 minus 2x square. And the second column, first to second column, 1 into x is x. 1 into x is x. Next one, x into minus 1 is minus x. X into minus x minus x square. Second column over. First to second column over. Next, first to third column, 1 into x is x. X into minus x minus x square. X into minus 1 minus x. This first row is over. And the second row, in the second row, now multiply second row and the first column. X into 1 is x. 1 into minus x minus x. X into minus x minus x square. Minus x square. And the second row, second column, x into x is x square. X into x is x square. 1 into minus 1 minus 1. X into minus x minus x square. Minus x square. And second row, third column, x into x is x square. 1 into minus x minus x. X into minus 1 minus x. X into x is x square, 1 into minus x is minus x, x into minus 1 is minus x. And last one, last third row. Third row, multiply third row and first column, x into 1 is x, x into minus x minus x square, 1 into minus x is minus x. And the third row, second column, x into x is x square, x into minus 1 minus x. 1 into minus x minus x. And the last row and last column, x into x is x square, x into minus x minus x square. 1 into minus 1 is minus 1. That is equal 1 minus x square is 1 minus 2x square. Next one, plus x minus x gets cancelled, minus x square, remaining element minus x square, plus x minus x cancel, remaining minus x square. First row is over. And the second row, x minus x, plus x minus x cancel, getting minus x square. And the second one, plus x square minus x square cancel, minus 1. The next one, x square minus x square, minus x minus x minus x minus x minus 2x. Second row is over. And third row, x minus x square minus x plus x minus x cancel, getting minus x square. Next one, x square minus x is x square minus 2x. X square minus 2x. And last one, x square plus x square minus x square. Plus x square minus x square cancel, getting minus 1. You have to prove the result. That is LHS equal to RHS. Prove is LHS equal to RHS. Hence proved. Now I am going to discuss second topic. Relation between a determinants and its cofactor determinants. Relation between a determinants and cofactor determinants. Let the determinant, let the determinant A is determinant of A equal to small a1, b1, c1. That is a determinant, the matrix a1, b1, c1, a2, b2, c2, a3, b3, c3. That is a determinant. The next one, cofactor determinants. Cofactor determinant is let capital A1, B1, C1 be the cofactors of small a1, b1, c1 in determinant A. Small a1, b1, c1 be the determinant of the matrix. The capital A1, b1, c1 be the cofactor of the determinant a1, b1, c in the determinant A. Therefore, the cofactor of determinant is cofactor of determinant is determinant of capital A1, B1, C1, A2, B2, C2, A3, B3, C3 be the cofactor of the determinant. Cofactor of the determinant capital A1, B1, C1, A2, B2, C2, A3, B3, C3 be the cofactor of the determinant. Now, product of two determinants. Next one, first one, determinant of A into cofactor of determinant A. That is the product of two determinants. The first one determinant of the matrix small a1, b1, c1, a2, b2, c2, a3, b3, c3 into, and the cofactor of determinant is a1, capital A1, b1, c1, a2, b2, c2, a3, b3, c3. Now, the product of two determinants. That is the determinant of matrix. This one is cofactor of determinant. Now, multiplication of two determinant. Now, taking row by row method. Row by row method. Row by row method is A1 into capital A1, B1 into B1, C1 into capital C1. That is the determinant of A. That is the determinant of A equal to determinant of A. Find out the value of determinant of A is small a1 into capital A1 plus small b1 into capital B1, small c1 plus small c1 into capital C1. That is the determinant of A. The determinant of A valued for the sum of the product of the elements. Sum of the product of the elements, any row or column with the corresponding cofactor in the value of the determinant. The sum of the product of the elements of any row or column with the corresponding cofactor of the value of the determinant. That is the determinant of A is capital small a1 into capital A1, b1 and small capital B1, small c1 into capital C1 is the value of the determinant A. The next one, the value of the determinant A equal to only possible for first row and first row, and second row. It is A2 capital A2 plus small b2 capital B2 plus small c2 capital C2 is, that is the determinant of A. Next one, third row is possible. That is the determinant of A equal to A3 capital A3 plus small b3 capital B3 plus small c3 capital C3 is only possible for determinant A. That is the rule is the sum of the product of the element of any row or column with the corresponding cofactor of the determinant, then the value of the determinant. That is the value. Otherwise, in first row, first column, that is first row and second column. Sorry, first row and second row, first row and third row. That is the value is 0. This is A1. First row is A1 and the second row. Multiplication of row by first row and second row. A1, A2 plus B1, B2 plus small C1, C2. That is the value is 0. The sum of the product of the elements with the corresponding cofactor of the determinant of any row, then the sum is 0. Sum is 0. A1, A2, B1, B2, C1, C2 values is 0. This A1, capital A1, B1, C1, C1 values is the determinant of A. A1, A2, B1, B2, C1, C2, that is any other row, multiplication of any other row or column, the value is 0. The next one, first row and third column, A1, A3 plus B1, B3 plus C1, C3 value is 0. First row, second row, third row, that is the value is 0. That is the multiplication of determinant, cofactor of determinant, value is 0. Second one, second row, first column value is 0. Second row, third column value is 0. Second row is, that is the determinant of the value of the determinant A. Second row is A2, A1 plus B2, B1 plus C2, C1 value is 0. Next one, A2, A3 plus B2, B3 plus C2, C3 values is 0. The remaining values is all are 0. And third row, first row value is 0. Third row, second row, that is the values is 0. That is A3, A1 plus B3, B1 plus C3, C1 values is 0. Next one, A3, A2 plus B3, B2 plus C2 values is 0. The only possible part, the determinant of A is A1, small a1, capital A1, small b1, capital B1, small c1, capital C1. The corresponding cofactor of the determinant, the value is the determinant of A. Otherwise, any other row, multiplication of any other row, then the sum is 0. Relation between determinant, cofactor of determinant based on an example problem. If ai, bi, ci are the cofactors of small ai, bi, ci respectively, here I value equal to I values is 1, 2, 3. 1, 2, 3 in determinant of A is small a1, b1, c1, a2, b2, c2, a3, b3, c3. So that the result is the cofactor of the determinant. Capital A1, b1, c1, a2, b2, c2, a3, b3, c3 equal to determinant of A square. We have to prove determinant of A square. Now, consider product of determinant, cofactor of the determinant. Determinant, cofactor of determinant. Now, consider product of two determinants. Consider product of two determinants. The first one determinant is the determinant of matrix A1, B1, C1, A2, B2, C2, A3, B3, C3 into the cofactor of the determinant capital A1, B1, C1, A2, B2, C2, A3, B3, C3. Now multiplication of two determinants. The first one is determinant of A and the second one is cofactor of determinant A. Now multiplication of two determinants. Multiplication of two determinants is, now I am taking row by row method. Row by row method. First row in first row. That is row by row method. First row is A1, small a1, capital A1. A1, capital A1 plus small b1, capital B1. B1, B1 plus small c1, capital C1. First row in first row. Next one, first row and second row. First row, second row. Multiplication of first row and second row, row by row method rule. A1, A2. A1, A2 plus B1, B1, B2 plus C1, capital C2. C1, capital C2. The next one, first row and third row, multiplication rule, row by row method rule. First row and third row, A1, A3 plus B1, B3 plus C1, capital C3. It is a row by row method multiplication rule. First row is over. The second row, first row, second row, and second row, third row multiplication rule. Second row and first row, A2, A1 plus B2, B1 plus C2, C1. And the second row is A2 plus B2 capital B2 plus C2 capital C2. Second row. Second row and third row multiplication rule. Second row and third row is A2 A3 plus B2 B3 plus C2 capital C3. Second row is over. And the third row and first row multiplication rule. A3 B3 C3 is the third row. It is A3 A1 plus B3 B1 plus C3 C1. And the second row A3 A2 plus B3 B2 plus C3 C2. And last row is third row multiplication. A3 capital A3 plus small b3 capital B3 plus small c3 and capital C3. Already you know small a1 capital A1, small b1 capital B1, small c1 capital C1 is the value of the determinant, that is equal to determinant of A. A2 B2 C2 values is determinant of A. Next one A3 B3 C3 is the determinant of A. The remaining A1 A2 B1 B2 C1 C2, the remaining values is 0. That is A1 is the determinant of A. That is equal to the first one is determinant of A. The second one A1 A2 B1 B2 C1 C2 value is 0. This value is also A1 A3 B1 B3 C1 C3 values is 0. That is values is 0. And second row A2 A1 B2 B1 C2 C1 corresponding any other row is the values is 0. That is this values is 0. And the second one A2 B2 C2 is his values is the determinant of A. This is the determinant of A. The remaining, the next one is 0. Last row A3 A1 B3 B1 C3 C1 values is 0. And second A3 A2 B3 B2 C3 C2 values is also 0. The last one A3 capital A3 B3 capital B3 C3 capital C3 values is determinant of A. This determinant of A, the remaining element 0. The diagonal only determinant of A. Now expanding the determinant. Now expanding the determinant in row wise or column wise anyone. Now expanding in row wise, now I am taking the element is determinant of A into eliminating row and column or eliminating getting the minor matrix. Determinant of A 0 0 determinant A. Determinant of A into determinant of A is determinant of A square. Next one 0 into 0 is 0. Taking the first element is determinant of A into getting the minor matrix. The answer is determinant of A square. Next one minus 0 0 and anything values is 0. Next one 0 taking the element 0. Next getting values is 0. That is equal determinant of A into determinant of A square is determinant of AQ. We have to show that the result is capital A1 B1 C1 A2 B2 C2 A3 B3 C3 equal to determinant of A square. We have to prove the result is determinant of A square. Getting the answer is determinant of AQ. We have to show that the result determinant of A square. Now I am consider determinant of A1 B1 C1 A2 B2 C2 A3 B3 C3 into capital A1 B1 C1 A2 B2 C2 A3 B3 C3 equal to determinant of AQ. Getting answer is determinant of AQ. We have to show that the result is capital A1 B1 C1 A2 B2 C2 A3 B3 C3 equal to determinant of A square. We have to prove A square. That is A1 B1 C1 A2 B2 C2 A3 B3 C3 is the determinant of A. That is the determinant of matrix. This is the determinant of A into determinant of A1 B1 C1 A2 B2 C2 A3 B3 C3 equal to determinant of AQ. To show that the result the cofactor of determinant equal to A square. That is determinant of A1, capital A1, B1, C1, A2, B2, C2, next A3, B3, C3 equal to determinant of AQ, determinant of A, this side, divide. Determinant of AQ by determinant of A, that is cancel, that is determinant of A square. We have to show that the result is determinant of A square. So the result, the cofactor of the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 equal to determinant of A square. Hence it is proved.